Kate, how might one go about simplifying this? Remember, the idea here is that there's this concept of repeated multiplication. So if I took this thing in question A and I wrote it out 3 times, then I would have 4 times 4 times 4, x times x times x, and y squared times y squared times y squared. Now, to avoid having to do that with the questions that get bigger, or even with the negative exponents and things just start to get a little more complicated, that's where the power laws have come from, to make your life a little bit easier. But they all stem from this idea of repeated multiplication. Okay, so with this, I can distribute the exponent, and when I do that, I multiply, right? Sorry, when I have powers raised to powers, I multiply the exponents that are, I just multiply the exponents. Okay, so I get 4 times 4 is 16, times 4 should be 64. That's what I was going to get, 64. X cubed y 6. Anybody got any problems with that? Okay, now, are we okay? Okay, on Friday we did these questions with a few of us at lunchtime. And there's always different ways to do these questions. Like, you could do them almost in whatever order you want. Sometimes there's like smart ways to do it, and maybe some ways that require a couple extra steps. When I see a negative exponent, like what I see in question B, I can, what does the negative exponent mean? Gabe? Yeah, so like essentially what's going to happen is you're going to put that -2 on everything, and then everything has a negative exponent, and then you're just going to have to flip everything anyway, right? And so right from the very beginning of this question, I would probably just flip the fraction and leave it as a, and then it has a positive exponent on the outside, right? So I'll get this. That was a lot of words for something that I think we're going to be okay with. Now, it doesn't change the sign on the stuff on the inside of the bracket. It's only going to change the sign on the exponent on the outside is what I'm dealing with right now, right? So I'm going to get 6xy to the -1 squared now, +2. Okay, now if you wanted to, again, you almost got this double negative. You do have the double negative piece going on. Like, if you wanted to reverse the 2 y's now, you can, but let's just see what happens. Okay, again, we should end up in the same spot. Why don't we distribute the squared on? Or we could reduce 2/6 to, what's 2/6 reduced?
1/3.
Okay, why don't you do that at the same time? Okay, and now I can distribute the squared on. So I get 1 squared x squared y to the -8 over 3 squared x squared y to the -2. Okay, and so I'm going to get what happens to the 2x squareds. Actually, I probably could have gotten rid of it. Yeah, they end up canceling out. They divide out. Probably could have divided them out up top too before I even distributed the x, or the squared, sorry. And so I'm going to get 1 over 9 y to the -8 minus -2. Be careful of that. When we have division of things with the same base, I subtract the exponents, and they're both negative here, so just be a little careful with that. You're going to get that double negative. Okay, so I get 1/9 y to the -6, and this is over 1, right? And then I can just move the y to the 6 to the denominator and be all done. Okay, I think everybody should arrive at this answer, but how you get there is going to change from person to person, and that's totally okay. There's probably 10 ways to do each of these questions if you really sat down to think about it. Everybody okay? Okay, let's do the next one. I'm going to deal with the squared in the denominator on the 2x. Okay, so I'm going to get 6x to the power of 4yz in the numerator over 4x squared times 3y squared z. Are we okay? So now I can multiply the 4 and 3 together in the denominator, right? And then I'll have some expression that I can kind of do some power law work to, right? So 6x to the 4yz over 12 x squared x squared y squared. I'll hit pause. I'll stop there for a sec. Make sure everyone's good. So here, this is what's going to happen now. Okay, I'm going to do, the z's can drop out. Everyone in agreement with that? You get one z in the numerator, one z in the denominator. They're going to drop out. The other way to look at this too is your power laws are just you like almost dividing stuff out. When it's quotient law like this, we're subtracting the exponents, but the reality is like how many y's do you have in the numerator and how many are in the denominator? Gabe?
You have 2 in the denominator and one in the numerator.
That's right. So the 1 in the numerator is going to divide out with 1 in the denominator. And so the exponent on the y squared is just 1. Right? There was 2 y's in the denominator and 1 in the numerator. And so you can divide out one of them. And you're just left with 1 y in the denominator now. Everybody see that? That is your power law, right? If you did that, it would be y to the 1 minus 2, which you would get y to the negative 1. What happens? You flip it. It goes down to 1 over y. That's where, again, the power laws are coming from that idea, right? And when stuff is strung together with multiplication, you can divide out like that, no problem. So again, let's take a look at the x to the 4 over x squared. You have 4 x's in the numerator and 2 in the denominator. So what ends up happening? What?
Subtract 2 from the 4.
You subtract 2 from the 4, you're left with just a positive 2, which means you're going to have x squared in the numerator. Okay, so 2 cancel with 2 up top, and you're left with an x squared. And then 6 over 12 reduces to what? 1 half. Okay, so we get, here's our final piece here. We're going to get 1x squared over 2y. Are we okay with that? You don't need to write the 1. I just wrote it there for the 1/2 purposes. Are we okay? So that, you're more than welcome to do the quotient law, but you can do this idea of division out as well. Okay? Are we good? Okay, this is pretty on point with the level of difficulty that I would ask on the test, I think. Okay, so if you're good with this stuff, you should be okay. Like E is pretty tricky, and we'll see how to deal with that in a sec. Okay. What happens when you have things of the same base and you're multiplying them together? What's the power law say? When you have things of the same base and you're multiplying, you add the exponents, right? Now the other component that you have here is the 3 times 6. That's done separately from the variables, right? Or the bases. So 3 times 6 is going to be 18. And then we have b to the 1/2 plus 4/3. So what do I need there in order to do that? Are you going to write down 4/5 on your page? Oh my goodness, don't do that.
No.
You need a common denominator. Gabe, what's the common denominator? Gabe, do you know?
You could multiply by 3, score over 3
Yeah, that's right. Not 1/2, but you're multiplying by 2 over 2 and 3 over 3. Do we see that okay? I'll write down a different color maybe. So you're multiplying by 3 over 3. Sorry. Not 3 over 3. 2 over 2. And 3 over 3 on the left. So you get 18 b to the 3 over 6 plus 8 over 6. Okay. All right, next one. I think the smart play here, sometimes you just gotta be, again, multiple ways to do these questions, but I think the clever way to do this is I recognize when I distribute the 4 in, I see something's gonna happen with the exponents. That's gonna make my life a little bit easier. As opposed to, you are actually more than welcome to do all the simplification work on the inside and then apply the 4 at the end. You can do that too. But this particular question, I don't really like the work that I'm going to have to do on the inside of the bracket initially, right? And so I'm going to distribute the power, like the exponent, in first, okay? And I'm going to get x to the 4 by 2, y to the negative 8, over y to the power of 4, x to the negative 7 times 4 divided by 4. Everybody see why I chose to distribute the 4 in now? Because I get x squared y to the negative 8 over x to the negative 7 y 4. Now, I'll pause there for a sec. That's a little bit tricky. Just make sure you're good with where all that stuff came from. Okay, the 4's dropped out there. We're just left with the negative 7. And 4 divided by 2 turned into the squared on the x. Okay, again, the distribution of the 4, the exponent 4, was the smart choice there. Okay, so now we can use our power laws, right? I'm going to get is equal to x squared minus negative 7. Again, just be careful with that double negative. Y to the negative 8 minus 4. So we get x to the 9, y to the negative 12, which is then going to turn into x to the 9 by y 12. Everybody okay? I do as many of these questions as you can, and then there's honestly, like, you go find the hardest ones, and these are freebies now, right? Like, this test should hopefully go well for most people. But the exception might be like the transformations. I think that could be a little tricky, the exponentials, and then the word problems might get a little dicey too. But all the work heading up into like the last little bit here, there has to be those questions on the test. So those are kind of freebie ones. If you do enough questions, can't really trick you with those. Okay, so let's take a look at this. A is kind of tough. I don't know if we saw any questions quite like A, or at least nobody asked about them. What can you do? Gabe?
You can start by turning the 4 into 2 by
Okay.
2 squared.
So Gabe knows that I need all the bases to match, and so we're going to turn the 4 into 2 squared. That's good. We're going to have to do that. Okay, because 2 squared is 4. And I need all the bases to match. 2, 2, 2 in order to do this work. Now what's the next thing? Robbie?
On the left, it can be rewritten as one really long division statement.
How do you mean? These are power laws, right? This is maybe the trick of the question, is that's a power law. The bases match, so what do you do with the exponents in the power laws? What Gabe answer? Gabe's doing well today. What do you got, Gabe?
You can just have it as itself the same base now, like on the next line, it'd be like, oh, all those fun stuff. You could have it, you could just have it be 2x plus 1 minus 2x.
That's right, buddy.
Minus x minus.
Okay, so good. Gabe's right. We're gonna subtract the exponents, but let's be careful here. You're taking the exponent in the numerator and subtracting the exponent in the denominator. You need to be careful with that. Okay? That'd be a question I think most people would lose a half mark on because they didn't. You'll see what happens in a sec. Okay? We're going to get, well, why don't we just write the bases now match, and so here's what we got. We got 2x plus 1. Now, if you didn't write the exponent in the denominator in brackets, you would have missed the distribution of that negative into the, you got to be careful, because now you got the wrong exponent, or the wrong solving, I suppose, right? You're only going to have minus x minus 3, but it should be negative x plus 3 with the double negative. You got to be careful of that. That's a tricky question. Okay, again, there have been a number of instances on this quiz in particular that have required you to be delicate around some of the double negative work. Okay, that I'm definitely going to try and trick you with that. Just be careful, because that separates somebody getting 100 to 95. There's small little variations. I'm going to see it very quickly. I'm going to know what happened, but it's going to separate the people from getting 100 to 95. Okay? Sorry, we don't need two equal signs in one line either. So we get 2x minus an x plus 1 plus 3 equals 2. So x plus 4 is equal to 2. X is going to equal 2 minus 4. Okay, again, the tricky bit is that careful with the application of the power law that was needed there. You're subtracting the exponents. Okay? What's the common base in B?
9.
Is it 9? Can you write 9 to the power of something to give you 27? 9 cubed is 27? 3 cubed is 27, right?
Okay.
So 3 is going to be the shared base between these questions. So I'm going to write 9. 9 is going to become 3 squared. And then I still have to have the 3x plus 1 there. Is equal to 27 turns into 3 cubed times x. Bases now match. And I get 2 times 3x plus 1 is equal to 3x. And now distribute the 2 in. 6x plus 2 is equal to 3x. 6x minus 3x is equal to negative 2. I'll stop there for a sec, make sure everyone's good. Okay, everyone okay?
Bless you.
Here, it's up here, Gabe.
Thank you.
Okay, so 6x minus 3x is 3x is equal to negative 2. Divide both sides by 3. Okay, everybody okay?
No.
You mean no?
No.
You mean no? Okay,
Oh. Okay.
that's still there. What do we do with the right side here? Hey? Oh.
Flip it.
Flip it. What happens if you flip it?
Negative.
It becomes negative.
But the exponent, not to the actual thing. It's like 125 to negative 1.
That's right. That's right.
Oh
So
my God.
5.
I'm today. Now, what else would it be?
Yeah. What else would it be?
Snake or something?
A snake. But lost.
Thank you.
Okay. Now what? Can't do anything unless the bases match. Owen?
5 exponent 3 is 125.
Okay, so 125 is 5 cubed times negative 1. And okay, bases now match. Everyone agree? So just ignore them. Then we get 2n plus 1 is equal to negative 3. So 2n is going to equal negative 4.